So this experiment does the heat transfer from pin fin, right? So you know that the fins are generally used to increase the heat transfer from any surface, right? So by providing the additional surface area for the heat transfer. So there are many applications for the fins, like you would have seen in the engines, right? The engines used for your bikes. There are fins all around the cylinder heads, right? So the purpose is to increase the heat transfer. Similarly, the domestic refrigerators, where you have fins like in the form of condensers and evaporators, where we provide additional area, surface area to increase the heat transfer. So in this experiment, so you have a fin, it is a cylindrical rod, that's why it's called as pin fin. So that fin is provided in the rectangular duct. Inside the rectangular duct, here it is there, inside. If you see from here, inside, so there is a fin is there. Okay, and we have thermocouples that are placed along the length of the fin at different locations, so that you will be able to find out the temperatures at the different locations. So this experiment is basically conducted to find out what is the heat transfer coefficient under forced convection and what is the effectiveness of the fin, right? And this we are doing at different flow rates, so that finally we be able to draw a graph between the flow rate in the x-axis and the heat transfer coefficient and the effectiveness in the y-axis. So there is a blower which is there, which is integral part of this setup, right? So you can the blower actually makes air to flow around the fin, right? So you can switch on the blower, right? And also you can control the flow rate of the air, right, which is flowing across the fin by operating this the delivery valve. By operating the delivery valve, we can control the flow rate. And so here there is a heater is provided. So with the help of the heater, you can just heat the fin, and so here you will be asked to do the experiment at different settings, voltage settings for the heater. So for example, if you are asked to set the voltage at let us say 70 voltage, right? So then with the help of the variac, you can set the voltage to 70, right? And you can set a particular flow rate by keeping the delivery valve at a particular position. Then at that particular valve position, at that particular voltage, you wait for some 5 minutes, so that the temperature along the length of the fin becomes steady. So there are thermocouples are provided on the surface of the fin, which can be directly read by the digital indicator over there, right? So the temperature at the various places can be measured with the help of these digital indicators. So you just have an eye on a particular temperature, let us say T1 for example, and wait that temperature T1 becomes steady. Once that T1 becomes steady, immediately you can take all the temperatures. So the last thing gives you the temperature of the ambient. So now the one set of reading is taken. So for a particular flow rate, you are getting the temperatures at different points, and also you need to find out the flow rate. So finally you will be drawing a graph between flow rate and the heat transfer coefficient. So if you want to find out the flow rate, so I need a flow measuring device. The flow measuring device used in this experiment is the orifice meter. So you have an orifice meter, and which is fitted with an U-tube manometer, right? So there are 2 points, one below the orifice meter and one after the orifice meter. So I can find out the pressure drop across the orifice with the help of the U-tube manometer, and by noting down the pressure difference, I will be able to calculate the flow rate with the help of the relations that is provided in the manual. So for each voltage settings, once the temperatures are stabilized, you are taking the temperature readings plus the manometer reading, right? So then you increase the flow rate. Suppose you are asked to take some 3 sets of readings or 4 sets of readings, you just keep at different positions as far as the delivery valve is. You just keep on closing it, right? And you can take some, you can maintain some 3 or 4 settings, and you can take 3 or 4 set of readings.